All right, so let's look at paper 2, question number 5. So Vishwa is standing at C, which is located in the direction of 20 meters north the house A. So A is the house. From A to C, the distance is 20 meters. Motorbike B is parked in such a way that bearing of the motorbike from C. So the very first thing that should come into your mind when you hear the word bearing is the north direction. That's the very first thing that should come into your mind. The next thing is you measure bearing always in clockwise. So it says bearing from C. So you got to start from the north direction of C and go till you meet the line that joins C and B. And what's this angle here? That's 116 degrees. All right. And it also says, and also it is east of the house. What is east of the house? The motorbike. So when they say something is in the east of the house, what does that mean? The angle between the north of the house and the line which joins house and the motorbike has to be 90. Remember, the angle between the north direction and the east direction should be a 90-degree angle. But they have already marked it for us, so we don't have to mark it. All right. The next fact. The gate D is located 20.5 meters away from B. So let's mark that information 20.5, the distance between D and B. Right. If angle ADB is 90, which is already marked here, uh, and the points A, B, C, and D are located in the same horizontal plane, calculate the bearing of D from B. So when you see the phrase calculate the bearing of D from B, that means there should be a north drawn at B. Is it already drawn? No, right? So you got to draw it. So let's draw the north. Let's draw the north of B. Starting from B, we drew the north direction. All right, that's the first thing we got to do. The bearing of D from B. So we got to start from the north of B and go till the line which joins B and D. So what we got to find out is this orange reflex angle's magnitude. This orange angle's magnitude, the size. All right, so what's the plan? How do we find? There's a problem. What's the problem? This orange angle is not an angle of any triangle. Yeah. So is it an angle of a triangle? No, right? So we cannot apply trigonometry and directly find the orange angle's magnitude. Instead, what can we do is, why not we do something like this? Let's try to figure out what this blue angle's value is. What's this blue angle? The blue angle I'm marking. So if I find out what the blue angle is, I can apply or I can use the rule of angles around the point as up to 360 degrees. All right, so how do we find this blue angle's magnitude? So students, this blue angle is consisting of three smaller angles. Let me put the blue angle like this, bit bigger. All right. So what are the three angles? What are the three angles? That's this E and the other tiny angle F and the other tiny angle G. So it's E, F, and G all together. E, F, and G three together makes the entire blue angle. All right. So we can easily find what's E plus F is. What should be the addition of E and F? Now, it has been told to us that the motorbike or the B is due east of A. So what does that mean? A should be in the west of B, in the west direction of B. So this line, which I'm going to draw in pink, the pink line I drew, was this. This is the west direction from B. So we know the angle between the west direction and the north direction has to be a right angle. So what's this angle here? 90. So E plus F is 90. All right. But still, we haven't found the blue angle's value. Why? Blue angle is not only E and F, it is consisting of three angles. What are the three angles? E, F, and G. So we have found out E plus F is 90. So what's the next thing we got to do? Find this blue angle's value. We got to know the G's value. I hope you are seeing the G here, G, the tiny angle that is marked here. All right. So how do we find out G's value? Can we apply trigonometry to find G's value, the angle G's value? All right. So first of all, angle G is an angle of which triangle? Okay, let's write it. Let's note it down here. G is an angle, is an interior angle of which triangle? The triangle that's at the bottom. Let me color that in some color so that you can see this triangle. So what's the triangle? G is an angle of triangle ADB. So it's an G is an angle of triangle ADB, the triangle you see at the bottom. All right. And what are we supposed to find out? We are trying to find out angle G's magnitude. All right. So remember, if you want to find, if the requirement is to find the magnitude of an angle, of a right angle triangle, and if you're trying to use trigonometry, you need to know the lengths of at least two sides. All right, so let's see. First of all, what are the sides of triangle ADB? That's, let's write it down here. AD equals, comma, BD equals, comma, and AB. I'm trying to write the lengths of the three sides of triangle ADB, the bottom triangle. All right. So what's AD? Uh-oh, AD is not given to us. So that's a question mark. What's BD? That is known to us. What's BD? That's 20.5. 20.5. And what's AB? Do we know what's AB is? The one which I've drawn in pink? No, right? So that's a question mark once again. Uh-oh, it's a problem. Why is it a problem? Because we are trying to find angle G's magnitude, but the problem is in triangle ADB, we know the length of only one side, but knowing just the length of one side is not enough to find the magnitude of an angle using trigonometry. So we are stuck. What's the plan then? Okay, I got a plan. Can't we find this pink side, that is AB's length, using the up triangle. Let me draw the up. Let me show you what I mean by the up triangle. Let me color it and show to you guys. That's this triangle, what I'm coloring now. Now, why did I get that idea? Because AB, this pink line I have drawn, is a side of both the triangles. It's a side of the bottom triangle, and it's also a side of the up triangle. And I feel like we can apply trigonometry to the up triangle that I'm coloring now in black. We can apply trigonometry to the black triangle here and find out AB's length. Shall we check whether it works? All right, let's see. So let's say applying trigonometric ratios, or let's say applying trig to triangle ABC, the up triangle, the triangle what you see at the top. All right. So what do we know about triangle ABC? Now, what's the goal? We are trying to find AB's length. Yeah. So applying trigonometry to triangle ABC to find AB. Now you may be wondering, why on earth is he trying to find AB? The plan is this. Once we find AB, then we can apply trigonometry to the bottom triangle and find out angle G's magnitude. Now, what is stopping us from applying trigonometry to triangle ABD? It is, we know only BD's length. So just knowing only BD's length is not enough to find angle G's magnitude. We need another side. So what we are trying to do is we are trying to find AB's length using the top triangle and then come back and apply trigonometry to the bottom triangle. Hope the plan is clear. All right. So applying trigonometry to triangle ABC to find AB. All right, let's see whether it works. So what do we know about triangle ABC? What are the things we know? We know AC equals 20 meters and AB is not known. That's what we're trying to find out. And what's the other side? BC. We don't know BC. We don't know BC, right? It is not given to us. All right. What about the angles? Angle A is 90. Okay, that is not going to be useful because that's useful. But okay, but we'll just write it. But angle A is 90. But we got to know the magnitude of one of the other two angles, because just knowing 90 will let us gives us a message that we can apply trigonometry, but we cannot apply any trigonometric ratios to 90-degree angle. We got to apply trigonometric ratios to other two remaining angles. Any way of finding out? Let me show the other two remaining angles in, maybe let's use a yellow color, the color that we haven't used. This is one angle, what I'm coloring in yellow, or this. Can't we find out one of these angles? Mm, can we? Yes, right? Because look at the angle, look at the yellow angle at C. We can apply the theorem of angles on a straight line. We know angles on a straight line add up to 180 degrees. All right? So then, what should be this yellow angle's magnitude, which is at C, 180 minus 116. So what would that be? That's going to be 64 degrees. So we got to know angle C. Oh, To be more precise, angle ACB's value. How much is that? 64 degrees. All right. So now what's the plan? What's our goal? Goal is to find AB, and we know one length and one angle. So if you know one length and one angle of a right angle triangle, you can use trigonometry to find missing lengths. All right. So what's the missing length you are trying to find out? The pink one, that's AB. This is our goal. We are trying to find AB. And have we fulfilled the requirements to apply trigonometry? Yes. To find a length using trigonometry, what we need is the length of one side, which we know AC is 20, and the magnitude of one angle, which we know angle ACB 64. So now we can apply trigonometry. All right, so now let's see. Now we figured out that trigonometry can be applied to triangle ABC to find out AB's length. So now we're going to decide what ratio are we going to use. So how many ratios do we know? We know sine, cosine, and tan. All right, so let's see which one can be applied. So we are we are going to apply this yellow color angle, yeah, the 64-degree angle, and we are going to we are trying to find out AB's length. So what is AB in relation to this 64-degree angle? What's AB? It is the side opposite to 64. So AB is opposite. All right. So closer to AB, within brackets, we'll write O, opposite. All right. And what length do we know, or what side's length do we know? We know AC's length. So what is AC in relation to this 64-degree angle? It is the adjacent side, right? So AC is adjacent. So closer to AC, let's write what? ADJ, adjacent. All right. So we know the adjacent and we are trying to find out the opposite. So let's see which ratio should be used. So what are the three ratios? Sine, cosine, tan. What is sine? Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tan equals opposite over adjacent. So, ka, toa. It's an easy way to remember what's each ratio's definition is. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is OA. What does OA mean? Opposite over adjacent. So out of these three ratios, sine, cosine, tan, which ratio are we going to employ to find out AB's length? Don't look at the picture now. We have a summary here. Adjacent and opposite. Adjacent is known, opposite to be found out. So pick the ratio which has A and O, adjacent and opposite. Which one has A and O? That's tan. So what to be used then? The ratio that to be used is tan. So what do we write? We write tan what? 64 degrees is equal to, okay, first we'll write the definition of tan. What is it? It is opposite over adjacent, OPP, opposite over adjacent. All right. So then tan 64 tan of 64 degrees is equal to, what's the opposite? You don't have to look at the diagram. We have written a summary here. What's the opposite? That's the pink side, which we have, uh, what's the name of it? That's AB. So do we know AB's length? No, that's why we have put a question mark. We don't know. So AB over. What's the adjacent? What's the adjacent? That is AC. That's 20 meters. So 20. All right. Now we got to find out what's the value of tan of 64 degrees is. So how do we find? This is a paper 2 question. So we can use the trigonometric tables. So we'll have to use the tan table. So in the exam, the trigonometric tables will be provided to you. So using that, you're going to find out tan 64's value. So let's see how to find tan 64 using the trigonometric table. So we are going to look at how to find tan 64 using the tan table. So tan 64 means it's 64 degrees and no minutes, 0 minutes, exactly 64. So where do we go to? We go to the 64th row. 64th row, 0th column. Why 0th column? It's exactly 64 degrees. There's no minutes. So what is in the 64th row, 0th column? It is 2.050. So that to be used in the place of tan 64 degrees. 2.050. So let's write it. So in the place of tan 64, we'll be writing 2.050 equals 8. All right, so I don't have space downwards. So let me take the workings here. So we have, what do we have? We have 2.050 is equal to AB over 20. All right. So how do we find AB's length? That's simple. Just a matter of solving this equation. So 2.050 division 20 goes to other side. What would it become? Multiplication 20 is equal to AB. So what is 2.050 times 20? Do the multiplication. When you do the multiplication, you will find out that to be what? 41. When you multiply 2.050 by 20, the answer is 41. So what's AB's length? 41 meters. All right, so now we know AB's length. All right, so that was the one which was blocking us from applying trigonometry to triangle ABD to find out the angle G's magnitude. But now we have got to know the AB's length. So now what can we do? We can apply trigonometry to the bottom triangle ABD. So applying trig to triangle ABD, they're trying to find angle G's value. So what are the lengths we know? We know AB, 41. While ago we found out. And what's BD? 20.5. All right. So you have to decide what ratio are you going to use in order to find G. So what's AB? Look at what's AB's. Where is AB? Is in front or it's opposite to the right angle. So what's the name we give to the side opposite to the right angle in a triangle? What is it called as? It's called as the hypotenuse. So AB is the hypotenuse. And what's BD? BD in relation to this angle G, what we are supposed to find out, BD is next to angle G. So what's the nice name we give to it? The side adjacent to angle G. So we have H and A. So let's see which ratio has H and A. So what's the easy way to remember the definitions of each ratio? So, ka, toa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. All right. So we're looking for a ratio which has H and A. Which ratio has H and A? Which ratio has H and A? So which ratio has H and A? That is the cosine ratio. It has A, H. So what you got to use is the cosine ratio. So what's the cosine ratio? What does cos mean? Cos of the angle you're supposed to find, that's G. Now I have labeled the angle to be found out as G, but you can use any letter you wish. Some of you might use theta, a Greek letter. That's perfectly all right, okay? So cos G is equal to what? What's cos is equal to? Adjacent over hypotenuse. So then cos G is equal to what's the adjacent? We have already labeled here, that's BD 20.5. So 20.5 over was the hypotenuse. Hypotenuse is 41. That's AB. Then what do we get? We have cos G. Cos of angle G equals what's 20.5 over 41? All right, there are multiple ways to get the answer. So let's see what's 20.5 divided by 41 gives us. So what's 20.5 divided by 41? Some of you would notice or would realize that 41 is the double of 20.5. So the ones who can realize, or ones who realize that fact, can easily get the answer. 41 has two 20.5s and 20.5 has one of those. So what's it? 1 over 2. 1 over 2 or half in decimal form is 0.5. So that's going to be the quickest one. If you do realize, if you did realize that 20.5 is the half of 41, you can easily get the answer quick. Or else the ones who did not realize 20.5 is the half of 41, what y'all can do is, one option you got is you can get an equivalent fraction. 20.5 over 41 can be also written as what? Both numerator and the denominator can be multiplied by 10. All right, why am I multiplying by 10? To get rid of the decimal so that it's going to be a bit easier, but not a must. All right, it's not a must to do, but it's going to be a bit convenient to work without the decimals. So 205, 20.5 times 10 is 205, 41 times 10 is 410. So now you can cancel 205 and 410. Some of you would realize at a glance that 410 is the double of 205. The others who don't realize that will have to cancel by 5. Then you can cancel. You can keep on canceling and get 0.5. Up to you. So 1 205, 2 205s. 1 over 2, that is 0.5. Or as you can also use long division. What is it? 20.5. See, there's no strict method to follow. I cannot pinpoint a strict method for this. Uh, it, it depends on your preference. You can use any method you wish. There are multiple methods to do this. All right. So how many 41s are there in 20? There's nothing. 0. 0 times 41 is 0. 20. 5 comes down. In 205, how many 41s? 40. How many 40s are there? That's 5. So 41s, it's highly likely it's 5. And 5 times 41, 205. So we get what? 0.5. You can use any method, or there can be methods other than these two. It's up to you, all right? So what is 20.5 divided by 41? It is 0.5 or half. So what is cos G is equal to? It is equal to half or 0.5. So now, how are you going to find G's magnitude? So what is G equal to? G is equal to, you got to put the cos to the other side. So when cos goes to other side, what would it become? G equals, cos goes other side. When cos goes other side, it becomes the inverse of cos. So how do you write cos inverse? Cos inverse. Instead of writing the word inverse, there's a special symbol to be used. You put a -1, like a power, like an index. It's not actually an index, but it looks like an index. What does cos and -1 at the top mean? Inverse of cos. How did that come from nowhere? It didn't come from nowhere because cos went other side. It became cos inverse. Cos inverse 0.5. So G equals, you got to find out 0.5's location in the cost table. Now remember, there won't be a separate table called cost table. Both sine and cos will be sharing the same table. All right, so let's see how to find cos inverse of 0.5. Let me show you the table. So we are searching for 0.5. So what does 0.5 mean? 0.5, and you see all here are in 4 digits, or rather it has 4 decimal places. So if you write 0.5 using 4 decimal places, what would it be? 0.5000. So we are hunting for this 0.5000. And where is it? It's here. Can you see? So remember now, just doing cosine. So remember, both sine and cosine are shared in the same table. But if you're doing cosine, where should you look at? Look for your right, this way, not to the left. Don't look at this 29. That is for the sine, all right? So that's 60 degrees. And how many minutes? Come down and see. Don't go up. Up is for sine. Down is for cosine. So it's 60 degrees and 0 minutes. So what's the location of 0.5? It's 60th degree row, 0th minute column. So 60 degrees and 0 minutes. All right. So what's cos inverse of 0.5? We found out while ago. That is 60 degrees and 0 minutes. If it's 0 minutes, you don't have to write it. You can simply put 60 degrees. So what's angle G's magnitude? 60 degrees. All right. All right. So we have found out G's value. G is 60 degrees. All right. So now we can answer the question. What was the question? The bearing of D from B, bearing of D from B. That is this orange angle. So what's this blue angle's value? That is 90 plus 60. What's the blue angle's value? 90 and 60. 60 while ago we found out. So 90 plus 60 gives us 150. So then what would be this reflex angle, this orange reflex angle's value? We know angles around a point add up to 360. So to find orange angle's value, what we do is 360 minus what? The blue angle, that's 150. That gives us 210 degrees. So the bearing of D from B is 210 degrees.